Welcome to TI Analog Design Contest 2012-13. We are representing Jadavpur University, Team 27-3. We are given the problem statement for Team C. Here we are showing the transfer function of the Taub-Thomas biquad filter that we have taken out by hand. We are just showing the step-by-step values of it. Coming on to the next page, showing the different voltages that we are getting, as well as giving the info about the final transfer function, that is V0 by Vi equal to -1 by 1 plus SCR square plus SCR. The final output is taken from this point, V0, that is the low pass filter. Okay, as we can also take the output from the band pass output from that V2 output. Okay, so next we are showing the software simulation of the circuit. We have used a PSpice software here. We are just showing the circuit simulation here that we have implemented of the Taub-Thomas biquad filter. Okay, next we are going to show the frequency, that is the body response, having the frequency magnitude as well as the phase. The above is the magnitude response with respect to frequency. The lower is the phase response with respect to the frequency.
Now let us come to the hardware implementation cut. Now let us come to the hardware implementation of the circuit. So here this is the power supply section. So for this we have used the power supply, and this power supply we are taking plus 10 volt and minus 10 volt voltages. Okay, which is coming from plus 10 and minus 10 volt voltages coming from here. And here there is an input that is simply the AC input that is coming from the function generator, and the input varies from 100 Hz to 1 kHz range, and the output is shown in the oscilloscope. Now come to the circuit diagram. Within the circuit diagram, actually there are three mainly phase. First is here this is the input section. Actually there are 4 op-amps TL082. Out of 4 op-amps we have used 3, and here the first section, the first op-amp, this section this is mainly the input section. Here this input is coming from here, and after this input, the output of this input, this section is this one, and this goes to this op-amp, this op-amp, and this is the input, and this op-amp is acting as a feedback part. Okay, and here the output, this output of this op-amp, this is mainly the band pass filter output, which can become the V2 as seen in the earlier case. And now this output is directly taken inserted into the last section, the last output section, the last op-amp, which is mainly the output section, and this is taken as an input to the op-amp, and via one capacitor, and the output that is taken, this output, this is the red color, this is the output, and this output is taken to and this is shown in the DSO, and the output is the low pass filter output, and this is the Taub-Thomas biquad filter without multiplier. Now we can use it by using a multiplier. If we insert a multiplier, NPY634 KP. Now there are 3 multiplier, analog multiplier, and we have taken the second multiplier over here, and in this multiplier, so there is one is taken for the input, that is this input of the multiplier is the band filter output that should be taken as an input, and the another, this pin mainly taken as the control voltage. As here the control voltage mainly varies from, well, they mainly have taken three control voltages, 1 volt, 5 volt and 8 volt. And we have taken these control voltages where there are 4 presets, 4 ports. Port 1, port 2, port 3, port 4. Here we have taken port 1 and port 3 for taking this control voltage, and we have taken port 1 for generating 1 volt and 5 volt, and port 3 for generating 8 volt. And this pin should be connected over here. And then we will go for multiplier. And here at this moment it is without multiplier. And when we will go for multiplier, then the connection will be simply like this. The output of the band pass filter now the output of the band pass filter, it is simply go at this position, and the output and the input to the output section, this is here.
Yeah.
Now we have to, now after this we will get a change in the output voltage. Now this connection we have simply inserted the multiplier. This is the output of the band pass filter. This is the connection with this is the input to the multiplier, and here we are giving the reference voltage from here, okay, and the output of the multiplier is mainly goes over the input to the input of the op-amp. Now we will take the output, this output taken from this red pin, and it is mainly shown in the oscilloscope. And this is the input response, and this is we are getting the output response simply as shown here. Now we have to conclude in this way that first of all we have to go through what are the challenges which we have faced while performing this task. First of all, we are coming to the why we are going for designing the circuit. First of all, actually I will tell you one thing, that as there are 4 op-amps, we have taken 3 op-amps. Here, the first thing is we have used this op-amp. Main the reason is that no such resistors or capacitors are present with this op-amp, so actually we need to connect this op-amp with resistors and capacitors, so we have not used this op-amp. Now coming to the another problem, that this op-amp, all these op-amps are connected, or all the non-inverting terminals of all these 3 op-amps are connected to the ground, but the non-inverting terminal of this op-amp is not connected to the ground. So we have connected a wire from the ground pin to the non-inverting terminal of this op-amp. Now we have faced another problem, that in case of input section we needed 3 1K resistances, but in the input section we are getting 2 1K resistances, but we are not getting the another one. So what we have done, that we have taken another 1K resistance that was present outside in a circuit, and simply we have used this 1K resistor which was present over here, and simply we have used this one. Now let us come to the multiplier section. Here for the control voltage we have used 4. There are 4 ports, and where we have used port 1 and port 3. The main reason is that the port 1 and port 3 voltage, the output we are getting the positive voltage, whereas in port 2 and port 4 we get the negative voltage. So we have to use this port 1 and port 3 only, and for that, as there are no other ports, so we have used for port 1 we have used 1 to generate 1 volt and 5 volt respectively. come to the challenges which we have faced during simulation.
Okay, the challenges that were faced are I'm just pointing out that is that the TL082, I've just designed it, I've just downloaded from the TI website and just have implemented this TL082. The modern understanding was a bit difficult part in the understanding. Next comes the part where the convergence error comes, as we have not taken the ground to be 0 point, so the convergence error came. But as we took the ground values to be, named the ground values to be 0, the convergence errors just vanished and we got the simulation results as we can see here. Next, coming on to the point of the challenges that we faced during the practical realization of the circuit, that is that mainly at the higher frequencies we saw that the oscilloscope is having a major noise input. Okay, so the actual measurement that we want to take was becoming really a tough one. Okay, next what we saw that at a very low frequency also it was very inconvenient to get the response or get the values. Okay, so it was really a bad experience here. Fine. Next, summarizing what we learned from our practical and the simulation realization. That is that we had a better insight of the PSpice software, as well as we had a knowledge of the TL082 op-amps, as well as the multipliers, how we can really use them to implement an analog filter. Fine. Next, going on with the problem statement, that the Thor-Thomas backward filter implementation was a bit of a tricky thing, but we did it and we had a very good results. Fine. Going on with the comparison between the simulation results as well as the practical results, and we saw a major difference between them, and we are just getting to know why the differences are there to implement a practical as well as a simulation part. That's all. Concluding to it. That's all. Thank you.